Hello, welcome back. If you are following up with my first video on this homework from May 6th, based on the common ion effect, pH and solubility, what we're looking at, so exercise 47. So here we have cesium iodate in a 0.2 molar solution of potassium iodate has a molar solubility, remember S, of 4.4 times 10 to the negative 8th molar, pretty small number. And here the problem wants us to find what is the KSP, solubility constant of cesium iodate. So thinking about it, what are we going to work with? Probably a rice table. So I'm going to go ahead and set that up. Okay, so I've set up my rice table, and I apologize, it's not cesium iodate, this is cerium iodate. So that factors into when you write out your equation of the charges. So my apologies there, but cerium iodate breaks up into cerium ion and iodate. And just remember to balance your equation, make sure that goes well. For assuming this is solid, we have these here, initial equilibrium, doesn't really matter, and it changes by this amount. And over on this side, what really does matter, initially we don't have any cerium ion, but the common ion effect jumps in here at our initial concentration. We know the solution has 0.2 molar potassium iodate. Obviously potassium isn't in this equation, so we don't worry about that. But we do know that it breaks up 1 for 1 here, so the iodate ion will match this concentration, so we can pull it down here, 0.20 molar. And then we can, increases by 1s. Remember the x could go here as well, but we're just trying to keep s for that molar solubility. This increases by 3s, and then we have those values here, and I forgot 0.20 plus 3s. Sorry about that. And then we can put this into our equilibrium expression, which I'll do now. Okie doke. So the rice table is set up correctly this time, factoring our initial concentration. Remember that common ion effect here is bam right here. And that's how it plays in. Set up your equilibrium expression, being careful with your exponents coming from the coefficients as normal, and then plug in those values. And here we are given S, the molar solubility in this situation from the problem. So you can just plug it on in there and then solve for KSP. Because always remember, what are you solving for? Here's KSP. So you can go down here. Once you've plugged in the values, this is super small and almost negligible, but the fact that the math isn't too difficult, we can just carry on through with plugging everything in and finding our value. So once you do all the math, you get a KSP of 3.5 times 10 to the negative 10. So that's the solubility product, that K value for cerium iodate. Cerium iodate. And that's how you do that one.